I hope that instrument is floating around so you guys can take a look at it, each one. So make sure you pass it around. It's a perfect instrument. If you go into this kind of business, it's a good instrument to get. It helps you quite a bit. This is about a couple grand. The other one is about $300. But if you do one job or two jobs, pays off for itself. Okay. A couple things. Now we're going to talk a little bit about the array location. What's the best location for it, so forth. So usually in a photovoltaic system, again, it's low density type of power generator. That's exactly it. The whole argument is, again, sometimes on the code is how you refer the photovoltaic system. Is it a really separate derived system, alternate power source, a service? I don't know. There's going to be a whole argument when we talk about it, when we interconnect it. And some of you guys who are electricians can help me out to define it. What makes it, alternate power source, separate derived system, or service. So in general, you're going to need a lot of surface area to get the certain amount of power. So you have to be able to calculate how much amount of power is used. Electrical bill, energy audit must be done. Usually to calculate the area that you need to actually design a system is what would be your desired output you want to get, the types of modules you're going to put, okay? The types of modules, and how closely you can put those modules in the area that you have. There are considerations as far as the mounting and the closeness that you put the modules, because what happens is if you put them too closely, which is a dense, then you have difficulty what? Servicing, moving. If you put them too far apart, then what happens? You're losing useful space that you can generate power. So you have to do some sort of what? Trade-off up there to see. The key thing is you must know how much output you want to get, your efficiency of the modules. And we're going to calculate this and how closely you're going to put them. Simple rule. There's a very simple rule up here. For the slab roof, you have approximate 12% efficiency. Okay? And this is, again, calculated type. There are modules that are 10% efficient. The modules that are what? 14% efficient. Under what? Under standard test conditions. Okay? So you need about what? 100 square feet for 1 kW of peak power. So this is a rule of thumb. Okay? So the area that you need is probably the amount of power that you use versus the module efficiency. Okay? That's the simple rule of thumb for some of you electricians to know.
Constantine?
Yeah.
When you look at a lot of the specifications on PV systems, they seem to all be, 50 kW, 100 kW, stuff like that. Do these engineers, are they really asking for that as an output, or are they using that as a relative amount of output?
Because the question was, a lot of the engineers, when you design a system, it's usually 3, 6, 9, 12, 15, and so forth. It works like that. Actually, it's not exactly that amount, because you might have like 4.6 kW system. Really, depending on because when you put the modules together and you connect them, you see that the numbers, they're not always, round up to 100, 100, and so forth. It's based on the calculations, really. It's based on the calculation. Because if you have a module that's 175, watts, and you put a certain amount of them together, and then you calculate the area that's required, so you end up with a number of modules and a number of power. But typically, you break them down into 3, 6, 10, and so forth. And a lot of times in the installations, because of the manufacturing of the rest of the components, combiner boxes, inverters, so forth, so you may have, for example, a KW system with 3 kW systems together, so forth. No. This is a rough order of things. So you say to yourself, how much area do I need? So for every kW, for example, you need around 100 square feet. So you go, again, look what we're doing. The objective is to do the site survey. So you look at the area up there, and where you go, you get a rule and you measure. So you said, okay, now you measure a certain area that you have 300 square feet. 300 square feet of empty space. Let's say 320 square feet of empty space. 330. So you said, in this particular area, it's facing south, I could put a system up there, 3 kW system. Now, you're not going to say 3 kW system to the dot. Approximately 3 kW system. Whether that system actually is going to give you exactly 3 kW on the best of it, now you have to do the rest of the analysis. Guys, I'm going to stress the point that it's not rocket science, but it's not you flip the coin and you got it made. You got to understand that. This is rough order for calculations, and there's precise calculations. Okay? If you're going to be off for it, you're going to be off for it for a lot. Rough order. You know, you have 300 square feet, you can put approximately 3 kW system. If you space a little more apart because you can service it and everything, so you might need more than 300 square feet up there. If you do a dense pack, this is what you're going to get. If you get modules that they give you 600 watts per square, 600 watts modules, and you're willing to pay the price for it, then you do the cost estimate. A lot of times you find out that you do what? Your cost analysis based what type of module you're going to select, because you can get manufacturers make modules that they give you what? 100 watts, 150, 175, and so forth. They have modules, I think now they give you as much as 300 watts. The cost associated with it. There is, so here's a typical array. The density of the module arrangement will affect the what? Accessibility. This is a dense arrangement, but this is what happens. What happens if you have to move to a certain location for that particular module in here? You need to do any work around here. What happens up there? Well, you better find some guy who can slide around underneath it. Or if you have to clean it, if you have to do anything. Or here, but you're losing a certain amount of what? Space. So you need a lot more area here than it is that you need up here. Considerations up there that you need to do. Not only considerations on the mounting these things, considerations also in running the wires and so forth later on. And before I forget, whenever you do an installation like this, do call for a rough inspection before everything is up there and somebody comes up there and says, what did you do? Or I put a, and you just call for a final. And somebody says to you, I want to see underneath what it is, all your connections. And make sure you have a cherry picker up there. Or lift these things up so I can see your connections. Remember your responsibilities as an electrician. So this is something that you have. And again, we're still talking about the site survey, which is extremely important. You measure the what? The slope orientation during a site survey. For rooftop installation, there's many ways you can measure it. You can measure it with an angle finder. This is the easiest way. Or if you are a roofer or a carpenter, you can use different other ways to measure. I'm not going to spend too much time about it. The easiest way to do it is actually, with a square steel level, you can do that. And any kind of method, I guess. Most of the times we were using an angle finder. It's a much easier way to do it. Now, if we don't know it, we got to learn it, that's all. Spend a couple hours reading the book, get an angle finder, and you will do it. If not, you hire somebody. You have to also understand, there's other people in this industry that have to make, not only electricians should make a living in solar panels, roofers got to make a living too, and carpenters and everybody else. Now, couple requirements for the array orientation is the azimuth orientation, okay? Is the direction such south-west, due south, that the slope surface is determined with a magnetic. You can put a compass up there to determine the actual orientation of different slope roof. You can use a compass. Now, some of that data also becomes available to you. But the best way to do it is by measuring and getting the now, the